Hello guys, welcome to another class. I hope you are watching my previous videos and the information provided by me is very useful for you, I think so. If you like my videos, please subscribe and comment if you like. If you don't like, also comment what I'm lagging. I'll just improve myself for for better explanation in the next videos. Myself Shiva, I'm also studying masters, and I had like more difficulty in finding the notes in the online platform, so I'm directly providing the information which is very useful for the exam point of view, and I'm providing the information which is not there in the online, so that please subscribe my channel and watch it till the end. And let us start with today's topic: atomic absorption spectroscopy. Atomic absorption spectroscopy and flame emission spectroscopy are quite similar in the instrumentation, and the principle is a bit different. That's it, and everything is almost the same, but the principle is different, some bit different. We will go through the details of the topic, then you can easily understand the atomic absorption spectroscopy. Okay. See, atomic absorption spectroscopy is an absorption spectroscopy. See, is an absorption spectroscopy method where radiation from a source is absorbed by non-excited atoms in the vapor state. It is the biggest difference in the from the flame emission spectroscopy. Here the absorption of light is measured, in the flame the emission of light is measured. This is the big difference, and this is the principle of atomic absorption, whereas in the flame emission it is the emission is the principle. In absorption, absorption is the principle by non-excited atoms. In flame, the atoms are excited to the higher levels or the excited state, where the energy emitted out is recorded. Here the energy absorbed is recorded. That's the main difference. Okay, I hope you are getting the point. Atomic absorption spectroscopy deals with the absorption of spectral wavelength of radiation by neutral atoms in the ground state. See here what happened, I'll just give you the diagram. You can understand betterly between the flame and absorption spectroscopy. Okay, see, in flame emission spectroscopy the energy HV is received by the atom, and it goes to the higher excited state, and it is where it is unstable and comes back to the ground state, and which releases the energy. Okay, this energy is measured by the detectors. Here in atomic absorption spectroscopy, what is happening, right? We measure the light at starting itself. See, when the energy, the radiation or the energy falls on the atom and it goes to the excited state. See, this how much energy absorbed by the atom, how much energy absorbed by the atom, this energy is calculated to determine the sample. This starting only we measure, right? This is absorption, not we does not calculate the emission. In flame emission, in atomic, the absorption, how much the amount of energy is needed for the excitation, it is the measuring or quantification of the sample. This is the basic difference and the basic principle and the mechanism involved in the atomic absorption spectroscopy. See, atomic absorption spectroscopy deals with neutral atoms, deals with absorption of spectral wavelength of radiation by neutral atoms in the ground state. I already said you the ground state, how much amount of energy is absorbed by the sample is calculated relatively by atomic absorption spectroscopy, reliable for detecting over 70 elements with metals and non-metalloids. Okay, there are only 70 elements that can be detected by atomic absorption spectroscopy. I will just give the diagram here, the table column, where you can just see. Okay, maybe you are seeing the diagram. Okay, these many atoms are can be detected by atomic absorption spectroscopy. Okay, next, the principle and the theory. The principle is based on the free atoms or gases generated in an atomizer can absorb radiation at specific frequency. Here the principle tells that the free atoms generated by the atomizer can absorb radiation at specific frequencies. Okay, next, Atomic absorption spectroscopy quantifies the absorption of ground state atoms in the gaseous form. See, it measures the absorption. It measures the absorption at the of ground state to quantify, means to identify the sample. Atoms absorb UV or visible light and make transitions to higher electronic energy levels. Here, they absorb the UV or visible light, they move from ground state to the higher electronic state or excited state, and the analyte concentration is determined from the amount of absorption. If the amount of absorption is increasing, then the concentration or the analyte concentration is higher. Okay, it is directly proportional to each other. If the absorption increases, then concentration is also increases, because see, if I am feeding you, you should also eat, right? If I am feeding less, you are eating less. That's what. If the intensity increases, the absorption you are taking more. That's it. That's the basic concept. I just gave the example. It will not be accurate. It like just see the definition. The analyte concentration is determined from the amount of absorption. Amount of absorption increases, analyte concentration increases. Amount of absorption decreases, analyte concentration decreases. This is the directly proportional to each other. Don't get that example. I think so. I've given the wrong example. Next, we'll go to the mechanism. What is the process or the mechanism involved in atomic absorption spectroscopy? Okay, starting the liquid, the sample is in the liquid state, forms the droplet by the nebulizer, where it sprays the droplets into uniform dispersed state. We already studied in the flame emission spectroscopy, same nebulizer we are using here. And fine residues formation of neutral ions. Formation of neutral ions are formed. Then neutral ions observe specific wavelength of radiation from the halo cathode lamp. This is the source of the light, source of the radiation. Okay, where the neutral atoms absorbs the specific wavelength, okay, of radiation, and the measurement of the intensity of radiation observed by the neutral atoms using a detector. Here we use a detector to find the absorption, how much amount of the sample is present and how much the light is absorbed. By this we quantify or we explain the sample nature. Okay, this is the mechanism. I think so you have understood. Next we'll go with the instrumentation. Okay, see, you are not seeing. Okay, this is the instrumentation. I hope you are seeing the diagram. This is very basic diagram. See, first I'll explain the starting. It is the light source, halogen cathode lamp. Okay. Next, the nebulizer is present in the atomizer itself. The nebulizer and atomizer are a combination of both, where atomizer converts the sample into the atomic state or neutral compound. Nebulizer provides the continuous supply to the atomizer. Okay. Next the halogen cathode lamp gives the light which falls on the monochromators, where a specific wavelength is sent to the detector. Here mirrors are used to reflect the beam into the detector. Okay. Next, a computer is readout devices. That's it. These are the instrumentation used. The detector is used, again the same detector is used in the UV and in spectrophlorometry and in flame emission spectroscopy, as well as in the atomic absorption spectroscopy. The most common detector is photomultiplier. The detector is used, the photomultiplier, as I already said you, the photomultiplier detector is very very important. So go and first learn that. Okay, the instrumentation I already said you, there are light source, nebulizer, atomizer, monochromator, detector and readout devices. Okay, we will go through one by one. First, the light source. Here we are using halogen cathode lamp. This is the most commonly used light source. Okay, it contains the voltage and a base, where a glass quartz window is placed and anode and cathode are placed. It may be made up of, the element may be made up of tungsten, okay, or any other, and it is filled with the buffer gas. Halogen cathode lamp is the most common radiation source in the atomic absorption spectroscopy. It contains a tungsten anode. Okay, I already said you it contains a tungsten anode and halo cylindrical cathode made up of elements to be determined. Okay, these are sealed in a glass tube filled with an inert gases like neon and argon. Each element has its own unique lamp, which must be used for the analysis. I said, see here the halogen cathode lamp is very specific for every element. For every element, we change the lamp. Okay. See here we said, see it is made cathode is made up of the element to be determined. If element to be determined is iron, it should be made up of iron. Okay, likewise it is very specific for every analyte. I think so I've understood the point. Next, the nebulizer. What is the function of nebulizer? It sucks the liquid sample at controlled rate. Okay, creates a fine aerosol spray for introduction into the flame. Mix the aerosol and fuel and oxidant thoroughly for introduction into the flame. Here nebulizer works in a way that the sample is sucked from, see here the sample, this is present inside it. Here it sucks the sample at a constant rate. Okay, and is introduced into the flame. This is the function of the nebulizer. Okay, next, atomizer. You can just tell by its name, atomizer. It converts the sample into an atomic state. Okay, we'll go through the details. Elements to be analyzed needed to be in atomic state. As I already said, atomizer means it converts into the atomic state. So the elements should be analyzed needed to be in atomic state. Okay, next, atomization is a process of separation. Atomization is a separation of particles into individual molecules and breaking molecules into atoms. Here atomization is a process involved in atomizer where the individual molecules are broken down into atoms. This is done by exposing the analyte at higher temperature in a flame or graphite flame. Okay, here the process of atomization is they expose the analyte to higher temperature or the flame. Okay, where the sample is converted to atomic state. There are mainly two types of atomizers mainly. Okay, there are flame atomizer and graphite tube atomizer. Okay, I have written it side by side. You can also write likewise. Next, we'll go through the flame and graphite tube atomizer. In flame, to create a flame, we need to mix an oxidant gas and a fuel gas. Okay, for flame atomizer, in most of the cases, air, acetylene flame or nitrous oxide acetylene flame is used in the flame emission atomizer. Okay, liquid or dissolved samples are typically used in flame atomizer. This is the properties or the how the flame and what are the types of flames used in the flame atomizer. In the graphite, see in the graphite tube atomizer, use a graphite coated furnace to vaporize the sample. Furnace is nothing but this is the furnace. Okay, here we are using uses a graphite coated furnace to vaporize the sample. In GFASS graphite furnace, sample are deposited. GFASS means graphite furnace atomic absorption spectroscopy. Sample are deposited in a small graphite coated tube which can then be heated to vaporize and atomize the analyte. The graphite tubes are heated using a high current power supply. Here the graphite tubes, see the sample is filled in the graphite tubes and the graphite tubes are heated. Okay, the graphite tubes are heated where the sample in the liquid state or the dissolved state converts into the atomic state by supply of high current power supply. Okay, I think so I've understood the both flame and graphite tube atomizer. Next, the main one, right, everything is main, but this is very important. This is very important part of atomic absorption spectroscopy. It is used to separate out all of the thousands of lines. Here the sample contain many like wavelengths, many radiations emitted by the sample. Okay, the monochromators, the main function is convert to polychromatic to polychromatic light to monochromatic light. Okay, here thousands of polychromatic light, poly means many, thousands of monochromatic lights are present, and we want a specific monochromatic light. For that we use monochromators. Monochromator is used to select the specific wavelength of light which is observed by the sample and to exclude other wavelengths. Here monochromators removes the other unwanted radiation and only transmits, only reflects the light which is required, okay, into the detector. See here, here diffraction grafting is used as a monochromator. We have already discussed about diffraction grafting in the UV spectroscopy. If you have not seen the video, just see the UV spectroscopy. Okay, next the detectors and the readout devices. The detector here is used, a photomultiplier is used as a detector, and the readout devices as usual they give the result on the computer, that is the readout devices. Okay, next, what are the applications involved in atomic absorption spectroscopy? In the next class we are going to discuss about the interference. It will not be an much lengthier video, but in today's class we will complete with the applications. Okay, determination of even small amount of metals like lead, mercury, calcium and magnesium. Next, environmental studies of drinking water, ocean water and soil. See, in atomic absorption spectroscopy the applications involved are where the metals and the non-metals are present, right, where the metals and metalloids are present, right, in detection of food, in detection of air, in detection of water, in detection of ocean water, everywhere where the metals are present you can add these applications. Okay, next, in food industry, pharmaceutical industry, soft drinks, presence of heavy metals in body fluids, everywhere where the metals are present you can just write it, in body fluids, in air, in water, in soil, and detection of heavy metals in the body, detection of heavy metals in the biological fluids, etc. Okay, by this we will complete the atomic absorption spectroscopy. In the next video we will start with the interference, and by this we will complete by today's class, and I'll make the in another video. By today's class we will complete the spectroscopy topics. Take on the notes. I think so I've understood the topics. I've explained it in an easy understanding way, I think so. Please add a comment if you like the video. Okay, if any problem you are facing, just tell me, I'll just try to rectify it. This is the diagram. Just show it out. This is the diagram of the atomic absorption spectroscopy and instrumentation. Instrumentation, the light source, the halogen cathode lamp, the nebulizer, atomizer, next, today's sun is very hot, yeah. That too, I'm not owning the fan because the fan sound comes in my wired earphone, so that I'm not using the fan itself, but it's too hot. Thank you guys for watching this video. If you like this video and you find informative, then please subscribe and comment and a thumbs up for me to motivate my day. Thank you guys. See you in the next class with a new information for you guys. Bye. Take care. Have a nice day.